Hi everyone, welcome to this video on the solutions to this year's 2017 end of year science chemistry paper. So I hope you have a copy of your paper and let's make a start with section A. Okay, so we have a diagram here which shows the particles of three substances, helium, mercury and zinc at room temperature. So based on what you know, we can identify that helium is a gas at room temperature, mercury is a liquid at room temperature, and zinc is a solid at room temperature. So all we want to do is to match the arrangement of the particles to the correct element. So in this case, X describes a solid, Y, since it is irregularly arranged but still closely packed, this is a liquid, and for Z, the particles are spaced far apart, so therefore this is a gas. So if we match that, helium is Z, Y is mercury, and X is zinc. Okay, so the answer is D. Okay, D is our answer for question number 1. So this is quite straightforward. Second question, plant dye X is a mixture, and we are told that chromatography is used to compare X with 4 other colored dyes A, B, C and D, and the results are shown. So since we have X on the left hand side here, okay, so we want to compare which, and the question is which colored dye contains X. So we want to see which of these A, B, C, D, okay, contain X. So look at this, the 2 spots that X has. So the dye of X is separated into 2 components, this one here and this one here. So all we need to do is to look across horizontally and find out which of the other ones contain both components. And in this case, we realize that only A contains both components present in X. B only contains one component in X, and C does not contain any component from X, and D contains only one component from X. So in order to have both components, our answer in this case is therefore A. Alright, moving along. Question number 3. Which apparatus, the apparatus shown below can be used to separate pure water from seawater, and where do water molecules lose energy? So this is a distillation setup. This is a distillation setup. Okay, simple distillation. Okay, and where do they lose energy? So it is where it actually condenses. Alright, it's where it actually condenses from vapor, from gaseous state to a liquid state. Okay, so the answer in this case is C. So let's take a look at why the others are wrong. So in this case, water molecules are not present in B, so B is out. A involves boiling of the seawater, so they are actually gaining heat. So they do not lose energy at A. And lastly, for D is already in water, so D is already water, and therefore it does not lose energy further since it's already converted to liquid state. So D is out. So the answer here in this case is C. Question 4. Which statement correctly describes the difference between a compound and a mixture? So let's take a look at the options. A compound can be crystalline, but the mixture cannot. So this is not really the main difference. Okay. B, a compound has a fixed composition by mass, but a mixture does not. So this is possible. This is quite close to what we have learned before. Option C, a compound is separated into its components by physical means, but a mixture cannot. So in this case, it is the mixture which can be separated by physical means. Okay, not a compound. So C is out. A compound sinks but a mixture floats. This has nothing to do with whether it's a mixture of compound. This is to do with density. Okay, so A is also out. Therefore, B is our answer. B is our answer. Okay, a compound has fixed composition by mass. but a mixture does not. For example, we have water, H2O. It has fixed composition by mass, 2 hydrogen atoms and 1 oxygen atom, whereas a mixture like air contains nitrogen, oxygen, carbon dioxide, and the noble gases, some of them. Okay, so moving along, question number 5. How many atoms can be found in 1 molecule of butanoic acid? So we are given the formula here, C3H7COOH. So let's count the number of atoms. We are interested to find out the number of atoms. So we go and count how many carbon, hydrogen, and oxygen. These are the 3 elements that are present in this molecule. So we realize that carbon, we have 3 plus 1 over here, that's 4. For hydrogen, we have 7 plus 1, 8. And for oxygen, we have 2. So this gives us a total of 14 atoms, and our answer is D. Next question, the proton number of strontium is 38 and the nucleon number is 88. Okay, so we are already given the proton and nucleon number. So just to recap, the proton number is the number of protons and the nucleon number, it is the number of protons plus neutrons. Okay, so how about the number of electrons? For this case here, for strontium, the atom itself, atoms are electrically neutral. Therefore, they have the same number of protons as electrons. So we started off with a strontium atom. It contains 38 electrons. Okay, same number as the number of protons. And then the question asked me, what is the number of electrons in strontium 2+? So Sr2+, okay, what has happened? Sr2+ ions, basically it has lost 2 electrons. So 38 minus 2 gives me 36 electrons. Because I started off with 38 electrons, I lost 2 electrons to form strontium 2+. This gives me 36 electrons remaining, and therefore the answer is A. Okay, so in order to find the electrons, we just compare the number of electrons in the atom. Okay, whereas if you ask to find the number of neutrons, that's where we take the nucleon number to minus off the proton number. So in that case, some of you who wrote 50, then you forgot that the nucleon number refers to the number of protons plus the number of neutrons. Question number 7, which element has the least number of valence electrons in its atom? Okay, so the least number of valence electrons, we are looking at the electronic configuration. So if we want least, we need to come up with we need to look at the electronic configuration. So for argon, argon is in group 0 and it has 8 valence electrons. Astatine is in group 7, so it has 7 valence electrons. Boron is in group 3, so it has 3 valence electrons. Potassium is in group 1, so therefore it has 1 valence electron, because the valence electrons correspond to the number of valence electrons correspond to the number to the group number. Okay, so in this case, our answer is D. Question number 8. The experiment shown below is used to test the conductivity of potassium chloride crystals. Okay, so in this case, we have a circuit and a lamp with the electrodes inside the potassium chloride crystals, which is in a solid state. And we're told that the lamp does not light up. But when distilled water is added to the beaker, the lamp lights up. So which statement best explains the results? So in this case, we have potassium chloride. Potassium chloride is a ionic compound. So straight away, when you look at this question, you should be able to identify that you think about the physical properties of ionic compounds, specifically the electrical conductivity of ionic compounds. So for ionic compounds, it cannot conduct electricity in solid state, but it can conduct electricity in molten or aqueous state. Therefore, obviously in solid state, in this case, it does not light up. But in molten or aqueous state, it lights up. Because when distilled water is added, it dissolves, the potassium chloride crystals dissolve, and it can conduct electricity. So from the notes, we have learned that in the solid state, the ionic compound has a giant lattice structure. So this giant lattice structure causes the ions to be held in fixed positions and therefore unable to move around to conduct electricity. However, when we introduce water, the giant ionic lattice structure is broken down and therefore the ions are free to move about to conduct electricity. So in this case, for electricity of electrical conductivity of ionic compounds, it is the ions, okay? It's the ions that move around to conduct electricity. And which ions in this case? We have the K plus potassium ions and the chloride ions which move around. Therefore, which statement best explains the result? So the keyword here is best explains. So option A says that an electron is transferred from a potassium atom to a chlorine atom. So this does not answer why the lamp lights up once water is added, right? This tells us about, so option A is describing the process of the formation of ions, which is not what we want. Option B, electrons are free to move in solution when potassium chloride dissolves. A lot of you chose this option, but as I mentioned before, it is the ions, not the electrons, that move around to conduct electricity for ionic compounds in aqueous or molten state. For option C, metal ions are free to move when potassium reacts with water. So this is already wrong. Potassium reacts with water, but in this case we have potassium chloride dissolving in water. Okay, and it is not only the metal ions but also the chloride ions. And therefore our option is the oppositely charged ions. So this refers to the potassium and chloride ions are free to move to when potassium chloride dissolves. So that's where the giant ionic lattice structure is broken down and the ions are freely moving. Okay, so our answer is D in this case. Our next question, question number 9, says that the boiling point of the oxides of beryllium and nitrogen are shown. So we notice that beryllium oxide has a very high boiling point, and beryllium is in group 2. So this is a group 2 and this is a group 6 element. Therefore, we know that metals and non-metals react together to form ionic compound, right? Whereas for nitrogen dioxide nitrogen is group 5, oxygen is in group 6. So non-metal react with non-metal to form a covalent compound. Okay, so based on what we know, ionic compounds have high melting and boiling points, whereas covalent compounds have low melting and boiling points. Okay, so this question is asking you why there's the difference in the boiling points. So let's take a look at the options. Option A, beryllium and oxygen atoms are bonded by strong covalent bonds. This does not really answer the difference. We are interested in the difference. Okay, so this is not to describe the bonding within beryllium oxide, in which case it is ionic, not covalent, so it's wrong. B, covalent bonds are weaker than ionic bonds. So a lot of you all chose this option. But when we look at the boiling point, for the boiling point of ionic compounds, we are overcoming the strong electrostatic force of attraction. But for the covalent compounds, we are overcoming the intermolecular forces of attraction. Okay, we are not overcoming the strong covalent bonds. Okay, so option B is wrong. C, intermolecular forces are weaker than electrostatic force of attraction. So like I mentioned, in the boiling point, we are overcoming the strong electrostatic force of attraction inside the beryllium oxide ionic compound itself. Whereas for the nitrogen dioxide, we are overcoming the weak forces between the molecules, not within the molecule. So it is true that intermolecular forces are weaker than the electrostatic forces of attraction. So option C is our answer. And nitrogen dioxide, option D, nitrogen dioxide exists as a giant ionic lattice structure. So obviously this is wrong because nitrogen dioxide, this is group 5, this is group 6. This gives us a covalent compound. So it does not have a giant ionic lattice structure. So the answer is C in this case. Okay, question number 10. The electronic structures of two atoms P and Q are as shown. P and Q combine together to form a compound. Which row describes the type of bonding and formula of the compound? So the first thing we do is to look at the number of valence electron. This will tell us whether it's a metal or non-metal, and therefore we are able to determine the kind of bonding that occurs between them. So let's take a look at the atom P. Atom P has 1, 2, 3, 4, 5, 6 valence electrons, whereas atom Q has 7 valence electrons. So with 6 valence electrons, it is from group 6, and 7 valence electrons, it is from group 7. Okay, so this tells us that both are non-metals, and as a result, they undergo covalent bonding. Okay, so covalent bonding, so options C and D are automatically out because ionic bonding occurs between metals and non-metals. Okay, so now the next thing we do is to look at the formula. So the formula, we are given two options, P2Q or PQ2. So let's take a look. In order to know how many, what kind of formula, we need to see how many electrons it needs to obtain a full octet structure, a full noble gas configuration. Okay, so for this atom P here, it is 2 electrons away. So it needs 2 electrons to obtain full valence shell, and therefore it will use 2 electrons for sharing. In this case, for atom Q, it is 1 electron away from achieving the full valence shell, and it will use 1 electron for sharing. Therefore, it will form the compound PQ2. PQ2, okay, because one atom of P will be able to form 2 bonds, right? Because it needs 2 electrons to obtain a full valence shell. So what I mean by this, if I were to draw the electronic structure, just showing the valence electrons, so I need 2 electrons to share, so I will use 2 electrons to share with Q. Q has 7, right? The circles are the electrons from Q. So 1, 2, 3, 4, 5, 6, 7. So it is missing 1, so it will use 1 to share. Okay, and then similarly on the other side. And then for P, it uses 2 electrons to share. So how many left? 1, 2, 3, 4. 4 electrons left. And this gives us our answer. So the answer is PQ2. Okay, so you notice that also for the outer shell in P, it has achieved the full valence shell. Okay, question number 11. Which pair of salts can be prepared using the same method? So let's recap. There are 3 methods to prepare salts. Which are the 3? The first one is precipitation. Okay, the second one is titration for spar salts. And then for the third one will be reactions of acids. Okay, so let's take a look. Ammonium sulfate and zinc sulfate. Zinc sulfate is a soluble salt. Ammonium sulfate is a spar salt. So spar salts are prepared using titration, whereas this one is prepared using reactions of acids, so A is out. Next one, barium sulfate and barium chloride. Barium sulfate is insoluble, so prepared using precipitation. Barium chloride is soluble, therefore prepared using reactions of acids. So, not the same method. Calcium nitrate is soluble and it's a non-spar salt, so it's prepared using reactions of acids. Copper 2 chloride is also soluble non-spar, therefore also prepared using reactions of acids. So C is a possible answer. And lead 2 chloride is insoluble based on our solubility rules. So this one is by precipitation. And sodium chloride is a spar salt, soluble, so we use titration. So D is out. Therefore our answer is C. Question number 12. An equation is shown. So we have this equation, we have C2H6 plus O2. We get CO2 plus H2O. So let's take a look at how to balance this equation. Alright, so let's take a look. If we have 2 carbons on the left but only 1 carbon on the right. Okay, so we need to have 2 on the right hand side here, 2. We have 6 hydrogen here, and we have 2 hydrogen here, so we need to top up with 3, right? Because in order to get 6, I need to multiply 2 by 3. Okay, and then I look at the number of oxygen I have. So on the right hand side, we have 2 times 2, 4, plus 3 oxygen, which gives me 7. So 4 plus 3 is 7 oxygen, but then in this case, we have O2. O2, so it's 7 over 2 O2, like that. So in order to make it a whole number, we need to multiply throughout by 2. Okay, we need to multiply throughout by 2. This gives us 2, 7, 4, and 6. Okay, because I cannot leave it in a fraction like that, and in order to have a balanced equation, my answer will be D. Okay. Question 13, which equation is not a neutralization reaction? So a neutralization reaction, just to recap, neutralization for the products are salt plus water, right? And this is a result of acid plus alkali or base, and we get our salt and water. So let's take a look at which is not a neutralization reaction. So in this case, we have, this is the alkali, this is the acid, we get salt and water. So A is out. B, magnesium plus hydrochloric acid, we get magnesium chloride and hydrogen gas. So this is not water. Okay, so this is our answer. Look at the rest. You also have the same base plus acid, we get salt plus water. Base plus acid, we get salt plus water. So C and D are also out. Question 14. A new indicator has been produced in the lab. The table shows the color change of the indicator at different pH ranges. So which two solutions can be distinguished using the new indicator? So what we want to do is to distinguish, meaning to tell them apart. Okay, so they need to have different colors in order to be able to be differentiated. Therefore, if we have aqueous sodium chloride, okay, so aqueous sodium chloride, all of these aqueous sodium chloride, they all have pH of 7. Okay, because sodium chloride is a neutral salt, so they have a pH of 7. So 7 gives me the color of purple. I need to be able to find another solution which has either red or green in order to tell them apart. So let's take a look. For hydrochloric acid, okay, hydrochloric acid, the pH is 1, right? A very low pH, is acidic. So it will give me a red color. Aqueous ammonia is a weak alkali, therefore it has a pH of around 9 or 10. Okay, and therefore this gives me purple. So purple, I do not want that because I cannot tell them apart. Aqueous sodium hydroxide, this is a pH of 13 or 14. Okay, so this gives me purple as well, so I don't want that. Aqueous sodium chloride and water is also pH 7. So this gives me the same color of purple, which I do not want. Therefore, my answer is A, because one is the one with hydrochloric acid is red, and the one with sodium chloride is purple. Question 15. Element X forms an acidic oxide of formula XO2. Okay, which group does the X most likely to be found in? So there's two clues in this question. One is acidic oxide. So which kind of elements from acidic oxide? You recall, acidic oxides are non-metallic oxides. Okay, they are non-metallic oxides. So non-metals is the first clue. So it is a non-metal, therefore option A and B are out because group 1 and group 2 refer to metals. Next clue, look at this formula here. So if it's XO2, XO2 tells us that we have 2 oxygens bonded to the element X. Okay, so in this case, the most appropriate answer would be C, right? C, which is 4, group 4. Okay, so a simple example you can think of will be CO2. Okay, carbon is the non-metal. It is also a CO2 is also an acidic oxide, and it will form this formula of XO2, right? So D is therefore out. Question 16, which statement of the periodic table is correct? So elements vary from non-metallic to metallic elements down the group. This is incorrect. It's metallic to non-metallic across the period. B, the reactivity of elements increases down the group. So this is not always the case, okay, as seen from the group 7 elements. C, the number of electrons of the elements decreases across the period. No, this is incorrect, because if proton number increases across the period, then the electron number will also increase. For option D, the number of electron shells increases down the group. Yes, this is true, because with every period, there's an additional electron shell. Question 17. Which trend best describes the melting points and reactivity for the elements lithium to rubidium? So these elements are from group 1, and we know that reactivity increases down the group, right? Okay, so this eliminates option A and option D. And for the melting point will decrease down the group, right? So will decrease down the group, and therefore our answer is C. Alright. Question 18. Which statement is true about noble gases? So for noble gases, they have unstable full shell structure. So it is not true. This is a stable full shell. So A is out. All noble gases have 8 valence electrons. This is incorrect, because helium is the exception. Helium has 2 valence electrons. Next one, all noble gases are flammable, so it's not true, they are not flammable. And lastly, D, all noble gases are monatomic. That is true, because they already have the full valence electron shell. And therefore, there's no need to gain, lose, or share electrons and exist as monatomic atoms. Alright, question number 19. Which diagram best represents an alloy? So an alloy is basically a mixture of a metal and another element. Okay, so looking at these 4 options, we can straight away eliminate A, because A is only comprises of one color of circles of the same size. Therefore, they are referring to one particular element only, so it's not a mixture. For option C, we have 2 different colored circles, but they are of the same size. So this does not, the question is asking you for best represents. So if they are of the same size, when you apply a force, they will still slide over each other. So C is not a good representation of an alloy. Option D, we have the 3 big atoms lying on top of this bed of smaller atoms, and this does not represent an alloy, okay, because when you apply a force, they will still slide over each other. Whereas for B is our answer, because if you look, it disrupts the orderly arrangement of the atoms, and therefore if you apply a force, it will not slide over, the layers will not slide over each other easily. Okay, question number 20, our last question for section A. Which statement explains why metals are good electrical conductors? So in this case, just now we talked about why ionic compounds are good electrical conductors in aqueous and molten state. It's because their ions are free to move. However, in metals, right, it is the electrons. It is the electrons that are responsible for conducting electricity. Okay, so for option A here, metals have closely packed metal cations arranged in a metal lattice structure does not tell us about the electrical conductivity. Option B, metals have free moving electrons that can carry electrical charges, so this is true. Okay, we know that the metal ions are surrounded by a sea of delocalized electrons, and therefore the electrons are the ones to move around to conduct electricity because they are very light. For option C, metals have lattice structure which allow them to bend easily does not explain why it is a good electrical conductor. So option C is out. And lastly, option D, metals usually have 1 to 3 valence electrons which are lost during a chemical reaction, does not explain why they are good electrical conductors. Okay, so our answer is B. So that's the questions for section A. I hope that this helps you in your corrections and revision.